Okay, I thought that I would go over the conservation of energy activity, and this one deals with skateboard physics. We'll be using another virtual lab, and I think that you'll enjoy it. It's very interesting, I think, and also is kind of cute. So when we have the conservation of energy, that basically means that all of the energy added together at one point has to equal all of the energy added together at another point. For this lab, we will only be dealing with kinetic energy and potential energy due to gravity. So our kinetic energy at point 1 plus our potential energy at point 1 added together has to equal the kinetic energy at point 2 plus the potential energy at point 2 added together. Now we can set up certain scenarios where we have maximum values. If we set the velocity to be 0, which is where we have our maximum height, then we only have potential energy. If we set our height to 0, where we have a maximum velocity, then we will have only kinetic energy. Remember that potential energy is equal to mgh, and kinetic energy is 1/2 mv squared. I know this looks a little funny, but this is just telling us that it's 0.2 maximum value. Don't forget the square. And we also need to remember that g is 9.8 meters per second squared. So that's our little introduction to the conservation of energy. Now we're going to take a look at the setup. We will go to this simulation, but first you will need to print the pages 6 through 12 of this document in order to be able to do your work. And later on, you will convert those pages into a PDF that you will insert or turn in a Dropbox in Blackboard. Alrighty, so let's go over to the simulation. When you click on that link, this is where it will take you. Of course, you want to click on the play. It might take a little while to load this. Give it a chance to do its thing. You're going to click on intro, and this is what it looks like when you open up the file. So there are some things that we're going to do in order to set this up. We're going to click over here in the left-hand side to show these energy charts. Underneath it, we're going to click on grid. Over on the right-hand side at the top, we're going to click on speed, unclick stick to track. Excuse me. We're going to leave the friction and the gravity alone, and we're going to set the mass to some value. It tells you which value to do in the lab. Finally, you're going to get to choose your skater. You can choose any skater that you want. I like the dog because I find it amusing. I'm not much of a dog person, but I do think it's funny to see a dog on a skateboard. So in order to make this work, you're going to click and drag your skater up to whatever value it tells you that you need to set your height at. For example, let's pretend like it's 5. So click and drag over here to 5, then I'm going to let it go and it should start moving. If it doesn't start moving, then you probably need to click on this blue button down in the bottom. Okay, so let's take a look at what's going on here. Notice over in our energy charts, we are sloshing back and forth between a maximum kinetic energy and a maximum potential energy. Okay, notice that when we have a maximum potential energy is when we have a maximum height. And when we have a maximum kinetic energy, we have a maximum velocity down here in the bottom of the valley. You're going to be asked to find the velocity down here in the valley. And the way that you do that is using these buttons down here. You need to stop it before you get to the bottom, if I can get that to work. Oh, that's really close. And then you will use this step forward button until you find the bottom. And I think that's probably as good as it gets. It's not going to be perfect. I don't think that's precisely the bottom, but if I go one more, then I will have to try again. This step forward button does exactly what it says it does. It only goes forward, okay? So my maximum speed is 9.9 meters per second. I'm going to write that down on my worksheet where it tells me to, and then I can start doing some calculations. It takes you through how to do the calculations, and we'll take a look at that in a little while when we look at the worksheet. but I wanted to also show you the other track that you're going to be using, which is the loop track. So over here on the right-hand side, I'm going to click on this loop. And it's also going to tell us to set this at a certain height. Let's do 5 again. And it'll also tell us to set a certain mass over here. I'm not sure what that is off the top of my head, so I'm just going to leave it at 60. And notice now the dog did not start. That means that I have to click on my little play button down here and loop to loop through the loop. Because this is not stick to track, if I don't set this value, the height, high enough, he will actually fall off the track, which is what would happen in real life. For example, let's do that. Let's set him down here at 3. And then he doesn't have enough energy to get through the loop, and he will fall off the track until he gets back onto something that's kind of stable. So no dogs are hurt, but he does fall off the track. All right, so for education purposes, let's go back up to 5 because I need to show what's going on. Okay, here you are going to be asked to find the maximum height so you can calculate your maximum potential energy. You will find your maximum velocity, which is not at the bottom of the loop, but at the bottom of the track in either one of these little valleys. Okay, so either one works. The maximum potential energy and the maximum kinetic energy should be equal. You're also going to be asked to find the height of the loop and the velocity at the top of the loop and calculate the energy at the top of the loop, which is just those two values added together. That should equal both the maximum potential energy, and then it also should equal the maximum kinetic energy. Alrighty, so let me stop this. Let's head to the worksheet and take a look at what we have. So I'm going to scroll down. These are your instructions, of course, and the percent error that you're going to use to calculate your percent error, of course. Okay, so here is your worksheet. You're going to do the valley scenario with one particular mass. You'll record your maximum height and your maximum speed, and then you're going to calculate your maximum potential and kinetic energies. You're also going to be asked to set this at a spot where the kinetic and potential energies are equal. So let me go back to the diagram, or back to the simulation, and go back to the valley. So if I set this at a value, let's do 5 again and start it. If I set this at a value, then you notice on the energy and the energy graphs, what we're going to do is try to stop this where those two bars are equal. Nope, not quite. Okay, now I can step forward. Okay, that is the point where these two kinetic and potential energies are equal. I would read this height. I would say in this instance that it's 2.5. Therefore, I can calculate the potential energy with 2.5. I'd read my speed up here as 7 meters per second. I calculate my kinetic energy with 7 meters per second. And then if I take a look at those, when I calculate it, they should be equal. Okay. I'm going to do a percent error between my maximum values. So this is the formula that I'm going to be using. You have to put this in your calculator correctly. I recommend using these parentheses, and don't forget to multiply it by 100 because that makes it into a percent. So just multiply it by 100. Don't worry about adding the percent sign. You're going to do the valley track again with a different mass, same kinds of things, and then you're going to do the loop track. So instead of finding the the point at which the kinetic and potential energies are equal, you're going to be dealing with the top of the loop. First, you'll do your maximum values, then you're going to do the loop, and you should find that when you add the loop two energies together, this energy of the loop, this should equal the maximum values for potential and kinetic energy. Then you'll calculate a percent error between your maximum values and that will be the end of your experiment. So if you have any questions, please let me know. Let me go back up here to how to make this into a PDF. So one of the ways, and this is not the only way, but if you don't have access to a scanner, then you can do it with your phone. Find an app. I had good success with this one, but I think actually Adobe also has an app that will create PDFs from images. You'll take pictures of all your pages. Please make sure that your pages are in order when you create the PDF. You should be able to reorder them fairly easily. Then create that document. I emailed it to myself to an email account that I also had access to from my computer. And then when I downloaded that on my computer, it was available to put in the Dropbox if I needed it to. Alrighty, so that is how we do this particular activity. If you have any questions, just email me and we will get it all sorted out.